Okay, hello students. Today we are going to learn about the next topic of the solid state. Okay, now here I'm going to share the PPT. In the last lecture, we are up to the uh, two dimension that is called as a uh, layer of the atoms in the two dimension. And now in this lecture, we are going to learn about the close packing in three dimension. In the last lecture, we are up to the close packing in two dimension, and in this lecture we are going for the close packing in three dimension. Okay, now in this close packing in three dimension, we are going to study now three crystal structure. The first one is called as the simple cubic lattice. So this is formed by the square close packing layers which are stacked only, and they will give you the simple cubic lattice. This we are going to study in detail also. And the second way is the packing of the hexagonal packed layers or hexagonal close packing, and these layers are going to stack in one another, and this will result in two different structure. The first structure with this is called as a hexagonal close packed structure, and the second structure is called as a face centered cubic structure. So we are in this 11th standard, we are going to study three structure simple cubic lattice, which is formed by the square close packing layers. The second is called as a hexagonal close pack structure, that is formed by the hexagonal close packing layers which are stacked on one another. They are supposed to be stacked in different two different ways, and the first is result in the hexagonal close pack structure, and the second way, if they are packed, they will give you the face center cubic structure. Okay, so first we are going to study about the stacking of square close packed layer. So this stacking of close packed layers of the square close packed layers, which we have studied also, that how the square close packed in the two dimension base. Okay, so just they are lying vertically and horizontally. Okay, and they will give you the two dimensional structure. Now, if this two dimensional structure is going to stack on one another, just like the paper or any two dimensional structure is stacked on one another, like a card or a paper, then they gives rise in the same manner vertically and the horizontally, and they this alignment will give you the structure that is called as a AAAA type of arrangement. Means the alignment vertically and the horizontally is same. So the layer which is formed, the new layer is formed called as A, means two dimensional arrangement is called as A layer. Again, if you are going to stacking the same two dimensional layer on this, it's called as again the A type, because its alignment are the same. Okay, and the third, if it is stacked two dimensional layer, then this is again called as A, because their alignment is same. So this will gives, or this will result in A type arrangement, and because of this arrangement the structure crystal structure is result. That structure is called as a simple cubic structure or primitive cubic structure. Okay, here the example is polonium. Here the example is polonium. So you can see here in the image, once again I'm going to repeat here, that this is actually the, if you take like this face, okay, or you can take this face. So if you I'm taking this face, now this is two dimensional structure. Okay, and we are going placing, or if you take the basement structure two dimensional, we are placing another same structure on this. Their alignment is same as that of this A layer. Second layer is also A. Third layer is also A, because their alignment is similar. Okay. The fourth layer is also the A layer, and this result in this structure of this structure can now take this four and this four, the below four, eight atoms or eight spheres, forming the simple cubic or the primitive cubic structure. So this is the arrangement, and this arrangement of the called as AAA layer. Now remember that we are calling this complete two-dimensional stacking as A layer. This complete two-dimensional stacking is called as A layer. Okay, so this will gives you the structure that is called as a simple cubic structure. Here the coordination number is 6. Now from this you can't understand the coordination number. Coordination number is the number of the atoms which are close to the given sphere. Okay, or there is a simplest nearest sphere. Okay, so in the next slide I'm going to give you the exact structure that is called as a coordination number is 6. Next is called as the stacking of two hexagonal close packed layers. Now here the stacking is like this. If you see here in the images, this gray color image here, this stacking is two-dimensional stacking, and this stacking is AB. Okay. Now this stacking we are in three dimension. We call this as the first A layer. Okay, so here the first gray colored layer is called as A layer. Okay, and here the second layer we are going to place here. This its alignment is not similar to that of the first layer, that is A layer. It is placed in the depression. You see here, this second layer is placed in the depression of the first layer, or it is called as a staggered conformation here. And because of this alignment, means the alignment is not same, so we call this as A layer. And now this one, the brick red color, this color layer is called as a B layer. So alignment is same, that's why it is A layer and B layer. When we are placing the B layer on the A layer with different alignment, then there is a generation of two types of voids. First one is called as a tetrahedral void, and second void is called as octahedral voids. This is very important. And a tetrahedral void is now generated by the triangular spheres, sorry, the spheres which are arranged three spheres, and if you are placing the fourth one, okay, and there will be a result of a triangular tetrahedral voids. So it is generated because if we are placing the sphere, or the when the sphere comes on the triangular voids, can you see here, this the back side of this sphere, there is a triangular voids. Okay, and when there is a sphere is placed exactly on that triangular voids, then in the inside that four sphere, the void is called as gap is generated, and that void is called as a tetrahedral void. Okay, later also we are going to study what is mean by tetrahedral void. So this sphere or this void is generated when we are placing the layer of the sphere of the second layer on the triangular voids of the first layer. Okay, so it is formed by the four spheres. Now octahedral voids, so we can see here these are octahedral voids also. So this, if there are inside the three gray sphere are there of the first layer, and if we are placing the three red spheres of the second layer, so it is generated when the triangular voids, means already there is a triangular voids of the first layer, and if we are placing again the triangular voids of the second layer or the other layer, then there is a generation of a octahedral voids. So octahedral voids is surrounded by total six spheres. Tetrahedral voids is surrounded, or it is formed by the four spheres. Okay, so this is the A layer and this is the B layer. We are studying the stacking of hexagonal close packed layer. Now, when we are placing the second layer, there we don't get any kind of crystal structure. Okay, so we'll go for the now the next, that is we are placing the third layer. Okay, before that, what we get here, the voids. So this is the tetrahedral void, and the shape here is tetrahedron. Why it is called as tetrahedral voids? So exact shape formed of that gap is called as a tetrahedron. Okay, so that's why it is called as a tetrahedral voids. Okay, so these are the three spheres of the first layer, blue color, and we are placing the this pink color sphere of the second layer. Then inside that, all the fourth sphere, the gap is there, the space is there. That is called as a tetrahedral hole. In here, octahedral holes, there are already the blue spheres of the first layer. There is a triangular gap, and we are placing on that gap the spheres of the second layer, pink colored, which also contain the triangular space or triangular voids. So triangular voids are, come align with the triangular voids of the second layer. And because of this, their alignment of triangular voids of the two sphere, we get a shape of the space or the gap that is exactly the octahedron. Okay, which is formed by eight sides. So that's called as octahedron. Okay, this is having the four side, this is having the eight side octahedron. Okay, so this way the tetrahedroids and octahedroids are formed. Okay, now this placing, we are now placing the third layer because we don't get any crystal structure. So now we are placing the third hexagonal layer on the second layer, which is also the hexagonal. So first is hexagonal layer of two dimension. We are placing the second hexagonal layer of the second, again two dimensional, and now we are placing the two dimensional hexagonal layer on it. Okay, so if we are going to place this, if this third layer alignment is same as that of the first layer, means if the first layer and third layer, they are coincide. Okay, if their alignment is same, then we get the pattern here is AB, means A layer is the first layer, B is the second layer, again the third layer is same as that, alignment is same as that of the first layer, then this is again called as A layer. So the pattern we get here is AB pattern. Okay, so arrangement of the sphere is AB arrangement, and this arrangement will result in a structure, crystal structure, that is called as a hexagonal close packed structure, HCP structure. Okay, now for example, that is here the magnesium, zinc, these metals are exist in the HCP crystal structure. Okay, so if we align the third layer of that of the first, we get here the structure that is the HCP structure. So this way, there is a, the diagram, it is very clear that this is the, suppose A is the first layer, hexagonal close pack layer of two dimension. We are placing this blue layer of second layer, which is also again the hexagonal HCP structure, but we now call it as a blue or the B layer, sorry. Okay, so this is the A layer, alignment is different that of the B layer. Then again we are placing the third layer. Here the alignment is now same as that of the A layer. So A layer, B layer, and third is again same. Alignment is same. So that's why it is called as A layer. So first and the third layer alignment is same. That will be result in the structure, and this structure is called as the HCP structure. So this is the HCP structure, clear cut here. Okay, so A layer, B layer, and again A layer. And get it? Hexagonal close packed layer. See here the arrangement of the first and the third is same. Can you see here the alignment is same? So this is the A, and similarly alignment is here. White sphere is same alignment. Only the between this blue sphere, their alignment is different. So this is the structure. So this arrangement up to this only is called as the HCP structure. Now if we are placing the different way, means A, B, and now if we are placing the C line or C sphere hexagonal HCP structure, then we get here the structure here A, B, and C. Okay, so this A, B, and C, here the structure here, third layer alignment is different. Okay, third layer alignment is different. So this is A, now this is B, and now the third layer is C. Okay, its alignment is same as that of A layer and B layer, totally different. Okay, if this is the alignment A, B, C, different way, if we are placing now fourth layer, their alignment is same as that of the first layer. So the pattern we get here is A, B, C, A, B, C, A, B, C. Okay, so fourth layer is same as that of the first layer. You can see here, if we are placing the third hexagonal layer on the second layer, then octahedral voids are covered. And if spheres of the third layer do not, align, the third layer is not aligned with the first layer, that layer is called as now C layer. Okay. Now sphere of the fourth layer, their alignment is similar to that of the first layer. The fourth layer is called as again the A layer. If alignment is same, the name is given as the same. Okay. So this will result in the pattern, stacking pattern is now called as ABC, ABC. So why again A? Because A, alignment is same. So A, B, A is different, B is different, C different, element different. But the fourth layer alignment is same as that of the first layer, and that's why the pattern will be ABC, ABC pattern. So if ABC ABC pattern is formed or if it is given, then the arrangement that results in the structure, that structure is called as CCP or FCC structure, same. So it is called as a CCP, means cubic closed packed structure, and also it called as face centered. FCC means face centered cubic structure. We know what is mean by FCC. Okay, so this will result in the structure FCC if the alignment is ABC, ABC, or the stacking pattern is ABC, ABC. Example here is gold, copper, and silver. So this way we get here, again we will go to see here what is the arrangement of the sphere. So this is the A layer. Okay, this blue green is A layer, the blue one is A layer, alignment is C. Can you see the alignment here is different, it is staggered. Again the C layer alignment is different, so A, B, C. So can you see here the structure in a unit cell, they are packed like this. The structure here is formed, is called as the FCC unit cell. So I'm going to see show here. Again, this is the A sphere, B sphere alignment is different, C is again different. Okay, so C layer is actually placed on this voids. Okay, these octahedral voids which are generated if we are placing the second layer, we get a new octahedral voids. Okay, and if C layer is placed on that void, we get a structure that is called as a FCC structure. Okay, so this way it is formed. And now here we go for the coordination number. Okay, and that is the end of the structure. So in HCP and CCP, coordination number is 12 in both this structure, HCP and FCC. Here the structure, the coordination number is 12. Now each sphere is surrounded by the 12 neighboring sphere. So what is coordination number? Is a close neighboring spheres which are in contact with the given sphere. Okay, so here the coordination number in FCC also and in HCP also, the coordination number is same. So if you take this as a sphere, it contains six spheres which are in the same layer. Three spheres are above this layer and three spheres are below that layer. So total here the sphere which are in close contact with the given sphere in either in HCP or FCC or CCP structure is 12. Coordination number is 12. So you can see here also the coordination number is 12. So next is what is mean by the uh, number of voids. How can we calculate the number of octahedral voids and the number of tetrahedral voids in a given FCC structure? Okay, so if the number of particles is n, then the tetrahedral voids which are formed are 2n. See, these tetrahedral voids are generated by the four sphere, the gap is there, and these voids are there even if the structure is formed. So tetrahedral voids are 2n. Okay, if the number of particles, number of total spheres or atoms are, if n, then the tetrahedral words generated, these are double of it, that is 2n. For the question it is asked, how many tetrahedral voids are formed or how many octahedral voids are formed. Octahedral voids are similar to that of the n. Now, if number of particles are n, the octahedral voids are formed are n. Okay, so this way I think we have covered the um, we have covered all this structure which are formed here, and in the next lecture we will go for the uh, topic that is called as the packing efficiency. Okay, and till then just take care, and we are going to stop here.